Now let us talk about array lists. In previous chapter we have introduced list data type as one of the three central data types of this class. You must have remembered that you can address position by their numerical index in a list, and you can get, set, insert and remove items in a list. And list is actually an expanding array. List is actually an expanding array. So list is right data type when you want some flexibility in your array, and that can only happen when you have something other than array, or you want beauty of array also and flexibility also. We have already seen linked list implementation, various examples we have seen, and in C++ it's very interesting to know that C++ owns a vector class which on the background use this linked list only, means list thing only. So before we go ahead, let me introduce, or let me iterate this class list which we have already made. In this insert, what we are trying to do is to insert this data into this position. Remove means at certain position you want to remove, and then to get at certain position you want to get. So in a linked list, if you can remember, there was a head. It was a head which was pointing to the first node, and it has two parts. One is value, one is the node or the address to the another node. And likewise this happens, and this goes on to the last one, which has the same structure, but the last one, last address is pointing to the null, right? Null. Okay. So using an array to store data internally will make reading and writing very easy. Order of one time. You have index, go to that index or value and just read it. But if you want to insert an element, if you want to remove an element, then what concerns you have? There are various concerns. First of all, you have to have these three variables such that you can actually handle them. The array means you have this array that contains all the data. This is the length, the number of elements we are going to store, and this is the array size. So what I am trying to suggest is, this is A, you know, this is having the address of the first element of an array. Length is the number of elements which we are storing. So say this is this, up till this point we are storing element, and then the size, whole size from this point to this point is your array size. Now what problems we can face? First of all, if you want that I want to insert an element or remove an element, then if you want to insert an element and the array is not enough, the size is not enough, then what you are going to do? You can make an array, and what size it could be? Another array, the size can be one more. The size can be one more. But there may be another chance also. Somebody could argue that okay, let's have an array of twice the size. In this way, we are not using more than twice. So wasting of space will also be covered. Means it will not be, the size will not be wasted. There may be other suggestions also. Means somebody could come and argue that okay, not twice, not plus one. Let's make an array of 10% size, 20% size, 30% size, right? This is the way people can argue, and this is how this data structure and argument goes on. In this array list, because we have suggested that we want to insert the value, we want to insert the value at certain position to this value, then we can just increase the length plus plus. What was the length? If you remember, length is the number of elements which are till now. We increase the number plus to 1. If length is greater than the array size, if this length goes beyond this size, then what we are going to do, allocate new array. So we are going to make an array and copy stuff over. All the array from the first array will be copied to another array with say +1, 10% or twice. So what we are going to do is we are trying to make a position POS by moving all entries from position to length 2, one position to the right. That is, you can think like this: from position to length -1, we are shifting AI to AI +1. But here is a simple consideration that this is not going to work, because we are already overwriting everything with a similar initial value. See, we are overwriting the value. So by the time we get to the position, this post +2, which is this position, let me tell you. If this is the position POS, then this is POS +1, this is POS -1, this is POS +2. So position 2, we get to the position 2 as we reach, we have overwritten it with the value of position +1, which itself has previously written with the previous and previous value. So to get rid of this problem, let's start with the length -1 or length -2 to be very precise. Let's start with this length -2 and come or reach till position, and now you can do this, no problem with that, and I-1. You have to notice that this index is length -2 because we have already incremented length earlier, and so length -1 is the last element that should be used in the copying to position I+1. So now shifting, we have shifted everything to the right to make room at the position POS, and now easily we can, this value can be transferred to a position. This is the implementation of remove function, which is quite similar. We can, by inserting, removing, these are quite similar. And let's come down to the basic question, because nobody is going to ask you in interview, okay, tell me how you use this and that. No implementation they are going to ask. They are going to ask, okay, you are trying to implement one with array, the other with list, tell me which one is better. This is what the exact question which I am going to address right now. What are the advantages and disadvantages? For array, you very well know in array it's order of 1. You go to some position, you can access. But what about inserting and removing? Let us first start with implementation which is based on our linked list, the linked list. So we have to find, or we have to go to the position I if we want to insert or remove. So linked list, as you say, it is like compartment of trains. They are linked, and you have to go to that compartment to remove or insert. You have to go to that position first, and that ith position is going to take you order of I time or order of I steps. Okay, so running time is OI. Once you go there, you can easily remove or insert. That is not a problem, right? Order of I is exactly what you're going to do, and getter and setter function will not be a problem because it will only take order of 1, just like array. But you have to reach to that node to actually remove and delete. And but once you are talking about arrays, for arrays, now these things have changed. This is an array, this is 0, this is I, and this is n-1. You want to insert or delete at this position. So what you have to do is, there are order of n-i or these n-i elements. So remove and insert element, we need to move all these elements to either right or to either left. If you are inserting, you have to move them to the right. If you are deleting, you have to move all the right values to one step left. So we get the ring time like this. In case of inserting for an array based implementation, what we can do, we have actually just thought about this, but we have not accounted one thing, that is cost of copying the entire array when the array needs to grow. So cost of copying also needs to be considered. This is linked list implementation, this is array implementation for get, set, order of I, order of I, this is order of 1, 1. But here, if for remove and insert, you have order of n minus I, while this order of I remains same for linked list. Okay, so there is a simple thing which we need to understand, that if we double the size, if you add the 10% size, but these things are there because ultimately you have to reach and you have to shift. So the average time that is taken over a sequence of operation, not over anything random, and this type of analysis which we consider somewhat advanced is called as amortized analysis. Amortized. So this is quite common in analyzing more advanced data structure, and we'll study them in later sessions. So the upshot of this table is that if we expect to be doing mostly get and set operation, there is no debate that an array based implementation will be best than the linked list. If we expect to do a lot of insert and remove, then we have to trade off between order I and order n minus I. So it doesn't make much of a difference. That is, linked lists do better when we access the first half of the list, while the arrays do better for the second half. Unless we have a strong reason to believe that our application really will prefer the second half. So one sense in which linked lists have advantage over this array is that most of their work only involves scanning over the list, while for arrays, much of the work is copying data around. This copying is actually the overhead. Writing data tends to take a bit longer than reading, so we could expect that array-based implementation is a bit slower than your linked list implementation. So hope you got the idea about today's discussion. Thank you so much. Take care of yourself.